it's a negative fraction. So these next ones are called literal equations, kind of, because you're not actually solving all the way till you get a numeric value. You're just gonna get, like, solve the equation for y, right? You're just gonna get y by itself. So pay attention. This, you may not know this one. Getting y by itself on this one looks like I'm going to subtract 3x. Remember, I'm trying to get y by itself. So subtract 3x, both sides. It'll zero out here, bring down the 7y. 14 minus 3x, those aren't like terms. You can't subtract 3x from 14, so you just have to write it out without actually doing the math, the calculation, that is. Divide by 7 to get y by itself. You can just divide the whole side by 7 if you like. However, 14, you could divide 14 by 7, so you could do that. You know, y is by itself now. 14 divided by 7 is 2. 3 is not divisible by 7, so you would just leave it as 3/7 x. I suppose if you left it like this, it wouldn't be that big of a deal, but you know, you could simplify the 14 divided by 7 to get 2. 3/7, you have to leave it. Get y by itself again on this one, so it's very similar, just subtracting again, subtract 4x, bring down the 9y, and then I get 27 minus 4x. And it's very similar to the last one, because other than the numbers are different, because when you divide by 9, divide 27 by 9, and then 4, you could just leave it 4 9s, right? So y is isolated, 27 divided by 9 is 3, but 4, remember, you can't divide that by 9, so leave it 4/9 x. Gonna keep plugging along here, guys. Still just getting y by itself on these next couple. So on this one, I'm going to subtract 4x. Oh, wait a second. These are the same problem. Sorry about that. I don't know why that keeps happening. So anyhow, we'll just move along. We'll skip that one. This next one, getting y by itself, guys, I think I'm going to multiply by 15. I don't really want to mess with these fractions. I'm going to multiply each term by 15 to get rid of the fractions. Even if there's no fraction, I have to multiply by the 15 to make sure the equation stays equivalent to the original. So 15 divided by 5 is 3. 3 times 4 is 12x. Here, 15 divided by 3 is 5, and 5 times 2 is 10y. And then here at the end, 2 times 15 is 30. So there's that. Now it looks kind of like the original, or the first view I did. I'm going to subtract 12x, right? Get the 12x away from the y term. 30 minus 12x. Now I'm going to divide both sides by negative 10, and this one I can only reduce, or actually 30 I can divide by 10, but 12/10 I can reduce. So y equals 30 divided by 10 is negative, or negative 10 is negative 3, and negative 12 and over negative 10 we can reduce that. First of all, negative number divided by negative number should be positive. And 12/10 is aka 6/5, so y equals negative 3 plus 6/5 x. And sorry about that, but there it is. Okay. So you could see in this last one, it talks about if the variables are eliminated, right? All the variables zero out, and the final statement we have is false, such as 2 equals 5, right? 2 doesn't equal 5. So if all the variables zero out and you end up with a false statement, you answer no solution. So moving along here, guys, I was just saying, so if you end up with a true statement, like 4 equals 4, for example, you answer all real numbers. Every number is a solution. Here we can answer all real numbers, ARN. So here, these might be special cases, right? No solution or all real numbers. Let's see here. We have negative 3x plus 5x. That's 2x. Just combining like terms. Bring down the plus 5. On this side, 4x minus 2x is 2x. Bring down the plus 5. I can already see the two sides are identical, but go on and do the next step. Subtract 2x on both sides. Subtract 2x. And when I do that, all the variables zero out. I know it's a special case if all the variables zero out. And so I'm left with 5 equals 5, which is true. 5 definitely equals 5. So if it's true, I answer all real numbers can be a solution to this equation, meaning any number I plug in on the left and on the right for x will result in equal values on both sides. If I plug in just a 0, right, I'll get 5 equals 5. If I plug in a 2, if I plug in a 10, if I plug in a negative 50, it doesn't matter what I plug in for x, but the two sides will always be equal is what that means. All real numbers. Here, let me go ahead and distribute to see what I got going on. So I have 2x plus 6 equals 2 times x is 2x, 2 times 4 is 8. I can already see the two sides are not identical, so that is kind of a clue. I subtract 2x on both sides, all the variables zero out, and I'm left with 6. Bring that down, and 8, bring that down, and 6 definitely does not equal 8, so this one is no solution. If you prefer the little symbol, you could just put, that as your answer. And then we just have this last section. So you had a bunch of equations with fractions and whatnot. You have special cases here with, special cases are equations that end with all real numbers or no solution. That's all that is. So, and then you have this last part. Actually, this last part is literal equations. That other one is that I sent that on was kind of like literal equations, but they call these literal equations where there's no numbers and you're just still solving for a letter. So I have to get, let's see, p by itself on this one. This one wants me to get b by itself. The next one wants me to get c by itself. And you can see it's a random equation kind of, or maybe it's not so random, like the equation for the area of a triangle. Either way, I'm supposed to get a specific letter isolated. So here I've got to get p isolated. So I'm going to start by subtracting the d there, both sides. So I end up with t minus d. Here the d zeroes out, but I still have pm left. Remember, I wanted p by itself, so all I have to do to wrap this up is divide by m. If I divide by m, it cancels out. So t minus d over m equals p. Remember, the objective here was to get p by itself. On this one, they want b by itself, so let me rewrite this. So if I want b by itself, I have to get rid of that 1/2 and that h. So if you just multiply by 2, right? If you multiply by the reciprocal of a fraction, which in this case is 2, you can get rid of it. This will cancel out. 2 times a is 2a. I still have bh here. Remember, I want b by itself, so if I divide by h, I'll have b by itself. So 2a over h, or 2a divided by h, equals b. That's that one. I'm going to keep moving along here, guys. This next one wants me to solve for c, so let me rewrite it. A equals, capital A, right, equals a plus b plus c plus d, all lowercase, over 4. So the capital A and the lowercase a are not the same value in this case. So I'm going to get rid of if I got to get c by itself, first thing I'm going to do is get rid of that 4 by multiplying. If I multiply by 4 to cancel, then 4 times a is 4a. I still have a plus b plus c plus d there, and I want c by itself. I'm just going to subtract everything away now because everything else is being added. I'm going to subtract a, b, and d to get c isolated, which will leave me with 4 capital A minus a and b and d. And again, c is isolated, so c equals all that mess. Last one, okay? So I'm trying to get y by itself, guys. So first thing I'm going to do here is subtract ax and subtract c, minus ax, minus c. Those will subtract over to the other side. Bring down the by. Bring down the by. By equals, over here I just had a 0, so 0 minus ax is just ax still. 0 is kind of irrelevant at this point. Subtracted the c also, right? A 0 out on this side. And if I want y by itself, my last step is just dividing by b. If I divide by b, I now have y equals negative ax minus c, divide by b. So use this as needed, stop and rewind as needed, and catch you next time.